Animating hair can be very tricky. It either looks very stiff or it takes you a very long time of hand keying the animation to make it look right. I'm Brian from Animate Academy, and today Vlad, our technical director, is going to show you how to use a simple cloth simulation in Blender, drive your hair controllers automatically, saving you hours of hand-keyed animation. By the end of this video, you'll know exactly how to set up a proxy rig, connect it to your rig and your controllers, and have Blender's physics system do the heavy lifting for you. Vlad, take it away.
Thanks, Brian. So the idea here is we're going to build a proxy mesh of sorts to do a cloth simulation, which is going to follow around with the head. And then we're going to use that to then drive the controls for the hair here. So I've got May's rig file open here. May's one of our characters. And I'm going to just go in here to the head and turn on the deformation bones. So if you're not too familiar with rigging, deformation bones essentially are just the bones that actually deform the mesh, and they're usually separated out from the actual control bones. So here you can see it looks a little bit complicated, but ultimately they're just simple bone chains. So there's just one bone parented underneath another and just kind of following in this sort of chain kind of pattern. And these green bones right here are the deformation bones. And the reason they're green is because they have a constraint put on them. And then these here would be the control bones, and they have a special shape attached to them so that they appear a little bit different, but that can be turned off right here. So if I disable this, you can see they're pretty much the exact same bone chain layered on top of one another. And so what we're going to be doing is we're going to be taking the control bone chain and the secondary bone chain. Now, in this case, I'm not going to be using the deformation bones directly. These bones are actually, for this setup, they're following another intermediary bone chain. And this just has to do with a rigify convention, which I'm not going to go into in this video. But I'm going to just turn off the deformation layer right here. I'm going to turn on this ORG layer. And the reason is because these bones act as intermediary bones, like I mentioned, and they hold the constraints necessary for the functionality that we're looking for. So if you're working with your own rig, what you want to have is just have one bone chain that has these two constraints, so a copy rotation constraint and a stretch 2 constraint. And then you want the control chain layered exactly the same way on top. And then these bones here are going to copy the rotation of the bone that they're layered on top of, and then stretch to the next bone in line right here. And the reason they're stretching to is because then we're able to translate this control here and have this bone actually point towards and stretch to that control. Now, it's not that we necessarily want the hair stretching around. The goal here is going to be that we're going to use the cloth simulation to drive the location of these control bones. So what I'm going to do to build the proxy mesh that I mentioned that we're going to simulate is I'm going to use a script, and this script is going to place a vertex point at each of the head and tail positions of these bones, so that we can then use that as a starting point to actually construct our mesh. It'll just save us a bit of time. So this script, I basically just went ahead into ChatGPT. I gave it some instructions about what I want to do. And if I just go over here to our text editor, I have a few scripts right here that we're going to use, and we'll provide these in the description. But this script right here, add point, add bone, is what I'm going to use first. So if you've never done scripting before, it's okay. I highly recommend dabbling in it a little bit. And I really like using AI tools for this, especially for relatively simple scripts, because it can give you a really good starting point and provide you with a great way to learn, because it provides these very helpful comments for each step that the script is doing. So you can kind of break it down and then learn some of the Blender API and some Python kind of as you go. So if we just have a look here quickly at the script, what it's doing. So first, it just makes sure we're in pose mode. It goes through and just finds all the bones that are selected. So right here, these selected bones, it iterates through the pose bones on the armature and just says, collect them if they're selected right here. If bone.bone.select, if this attribute is true. And let me just zoom in just a bit here. Now, if there are no selected bones, it'll just give you an error, and then it'll go through and just collect the head and tail world space positions for all of these bones. Then it just goes ahead, creates a new mesh, links that mesh to this scene, and then actually creates those points on that mesh. So that's it. It's relatively simple, but it does save us a whole lot of time doing that kind of stuff manually. So I'm just going to zoom out here, and I'm going to go through and select all of these bones here that I want to actually simulate. So I'm going to leave these bones up here just to maintain that rigidness at the top of the hair. And then I'll select all of these bones here. Okay, so now that I have all of these selected, I'm just going to go ahead and hit run script up here at this icon. And if we go to X-ray here, it's hard to see, but if I go back to the outliner here, it created this new object. If I go to edit mode, you can see it made a new vertex point at each head and tail position on these bones. So this is super helpful because now we can use this to build out the mesh. Now, before I do that, I'll just add a new collection here. So I like to organize my rigs, just having one collection for all the geometry, one collection for all the rigging elements, and now for the simulation elements, I'm going to just make this may-sim collection and then right click and give it another color. And I'll just throw this geo in here. Now to create the model we need, I'm going to go into edit mode with this new mesh that we generated. And I'm going to first connect these points. So I'm just going to do the first strand of hair here as an example, and then I'll just do the rest off camera just to save time. But the way I'm going to do this is I'm going to select these points right here, one at a time, actually two at a time. And to connect these, to make an edge between these, I think the default key is F, but I made mine Alt F because I use F for focusing on selected. And I'm just going to do this for each of these. Create a... Oh, and it looks like there might be duplicate points here. Before doing that, I'm just going to select all the points, hit M, and then just merge all of them by distance. So just in case if there's any points that are directly on top of one another, it'll make sure to merge them together. Okay, so these look like they're connected. Now I'm going to take this and I'm going to hit E and extrude it to the side like this. Just hold shift to do more minute movements. And then I'm going to select this edge loop again, which by default it's Alt left click. And I'm going to extrude it to this side as well. Okay, so I now have this kind of plane that's extruded that's following along the bone chain exactly. Okay, and this is what we're going to use for the cloth simulation. Now, for the sake of stability for the simulation, we can just add another edge loop in between here just to make them a little bit more like quads. I find that helps to make things a little bit more stable when calculating the cloth mesh. And now I'm just going to go ahead and make this mesh for all of the other hair pieces. So I'll be back in a sec. Okay, so the final result looks a little bit like this. We have a strip for every single bone chain on the hair here. Now yours might not have nearly this much, I don't know, but I just went ahead and repeated the same process that I did for the first one. So I just connected all of the vertices and then extruded one way and extruded the other way. And if we just do / here, that'll isolate it so we can see it locally here. Now going into X-ray mode, you can see one side is darkened out and one side is bright. So that's the way the normals are facing. So I actually want to flip this the other way. And for that, I'll just hit Alt N and then the normals just hit flip. So it'll flip them to the outside. So now what we're going to do is we're going to switch back to the armature here. We're going to deselect these bones. And now we're going to use another script to generate empties at the same locations, the head and tail locations of each bones, so that we can then parent those empties to the vertices on the new object that we just created. So that way the empties will be able to follow along with the simulation. And then we're going to use another constraint on the controls themselves to constrain the controls to those empties. Okay, so I'm going to walk through how to do that now. First, I'm just going to select all of the controls that correspond to these bones, so the same controls here, because the script that we're going to use is going to derive the names for the empties based on these selected controls. And that'll just make it easier when we need to constrain the controls back to the empties. So I'm just going to go through and finish selecting all of these here. Now I'm going to switch to the text editor and I'm going to select this script here, add empty at bone. So this script is very similar, except like I mentioned, it just creates some empty objects at these locations. So I'm going to just run the script and then switch back to the outliner here. And we see all of these empties here now, and they inherited all of the names from the controls. And it made sure to grab these last tail components here. So we have these empties like this. So we have this one here for the head, and then one for the tail on the last bone here as well. Okay, so now let's just parent these empties to our mesh object that we created. So I'm going to just select all of this here, hold shift, all of these objects, and then I'm going to do / to isolate them. So essentially these empties are acting as sort of intermediary objects because you can't quite constrain bones directly to vertices or have them follow along with vertices on mesh objects, at least at this point in time in Blender. In the future, there might be some geometry node tools that come along that make that easier, but at the moment, we're just going to use these empties as sort of intermediaries to allow our claw simulation to drive our bones. So the way you can parent an empty object, or any object really, to a vertice is I'm going to select the empty first, then select the mesh, hit tab to go into edit mode, and then I'm going to click on the point here, which the empty is sitting on top of, but the point that I want to parent to, and then just hit Control P, and that will, you can see here, it parented the empty under the object, but it's actually directly under the vertex. So if I move the vertex, you can see the empty is now moving. And so I'm going to go ahead just one by one here. I'm going to just parent each empty to the vertex that it's sitting on. So once again, I'll just skip forward once I'm done. All right, so they're all now parented to the vertices, following along. So if I just select all of them, make sure that none of them are left behind. And now I'm going to unisolate this here. And what we want to do is assign vertex weights for these top vertices here so they can follow along with the head. And it's also going to act as the pin group for the simulation. The pin group is basically just the vertices that are pinned in space. So they're going to follow along with the head and be pinned so that they don't simulate, so that all these other vertices down here will move around and respond to the movement. So I'm just going to switch to the property window here, go to the data tab and add a new vertex group. And I think on this rig here, if I open up the bone collections here and switch to the deformation bones, the head deformation bone is called DEF spine 007. So I'm going to copy this and go back to the hair object here. And I'm just going to paste this name right here. So whatever the deformation bone on your rig for the head is called, you want to just put in this name right here. And we're going to assign all of these top verts to this group right here. So I'm going to just solo this again so it's easier to see. And then I'll just circle select these top vertices here and then just hit assign. Now these ones down here, I kind of want to just assign them as well, but not 100%. So maybe something like 50%. And hit assign. Okay, and now I'm just going to parent it to the armature, Control P, and add an armature deform modifier. So there we go. So now if we move the head, I'll turn off this. So if we move the head, it's kind of hard to see, but the top vertices should be following along. If I just enable this right here, so you can see they're moving along with the head. And that's what we want. Now, I don't want to permanently create a simulation system on this rig because most cases I might want to just animate the hair manually. So I'm going to just leave this setup as is in this file. And I'm going to go ahead and open up the scene file that has all the character animation that I want to do the simulation on. And we're going to continue from there. All right, so here we are in the scene where we have all of our character animation and all of the rigs are linked in, including May here. And we can see the sim collection that we created with the bone vertex cloud. I just hit it for a moment here. If I enable it, you can see it looks a bit weird because only the tips of that mesh that we created are actually following the head because that's the only part we assigned, right? So the rest of them are back at origin, which is right here. You can see the red and green lines. So that's the origin of this scene. And what we're going to need to do is we're going to need to simulate all of this geometry into position before the actual scene starts. The thing to keep in mind with simulation is that in order to calculate the position of the geometry at any given point, we need to know what came before. So the frame before the current frame. So it's kind of like if you're doing straight ahead animation, you're just animating one frame at a time. And so in this case, because May's starting position in this scene is way over here, offset from the origin, we need to slide her into position in order to allow the simulation to calculate what the actual starting position of the simulation should be. And to do that, we have to basically just offset the animation for the entire scene, something like, I don't know, like 100 frames, 150 frames, something like that, and allow it to settle before the animation actually starts. So I'm going to go into the action editor here. I've got the action editor selected here. This is the action, the box animation, and I have all of the characters and all the animation in their own individual action slots. I want to select everything. And before I do that, just make sure that you have this icon enabled right here, which is make sure that all of the keyframes for all of the channels are visible. So in case anything's hidden in the viewport, it's going to be visible here in the action editor. So I'm going to hit A to select all the keyframes, do G, and then we'll just type 150 to offset the entire animation by 150 frames. And then if you just scrub here, you can make sure that there's no keyframes left behind and there's no animation happening in this region right here. Okay, so now let's take May, and I'm going to just make sure that her starting frame right here has all of her controls keyframed, which it looks like they are. Because now if we go back to frame 1, just select everything here, and I'll do Alt R, Alt G, and Alt S. And it looks like I scaled her down just a little bit for the scene, so that's why we need to make sure to clear scale as well. So everything should be back to its root position here. Now if I scrub and have a look at how it transitions into the starting position here. Now I think it would be best if the animation started a few frames after she actually settled into position. That way the simulation has time to kind of settle in. So I'm going to take all of these keyframes right here and just do Shift D to duplicate them and just move them a little bit earlier like that. So now we have this sort of buffer region where the animation can settle down. Okay, now let's go back to the starting position here and let's now enable the simulation itself. So let's go in here and select our mesh object that we created. So let's go in here and select our hair simulation object. And I'm going to go to properties. Now, if you go to the physics tab here, everything's going to be grayed out because this is a linked mesh. So in order for us to do some simulation on this mesh in this scene, we need to first create an override on the geometry data. So for that, we can go here to the object tab. And here at the top, where we see the name here, you can see this button here, which is the library override. So if we click this, and if we go back to the simulation physics tab, you can see these are now available to us. So now just go over to cloth and click it to enable it. And we've got all these different properties. Most of them, honestly, I don't touch. We don't need to touch them. The main ones right here are the quality steps and the speed multiplier. So usually I set the speed multiplier a little bit higher, so either 2 or 3, depends on what it is. Essentially, the speed multiplier just helps the cloth move a little bit quicker, which I find is useful most of the time because it tends to do this very swimmy, kind of flowy motion at the default setting, which makes it feel like it's underwater or something. So I try and experiment and bump this up, sometimes going even higher, like 4 or 5, depending on the situation. The quality steps will just give stability to the simulation and some accuracy. So if the lower this is, like 5 is quite low, sometimes it can cause like jittering or stuttering or intersections, which can cause it to glitch out. I'll just set it to maybe 8 for now, and then just so we can see a preview of it. And then once we do the final, I'll try and bump it up a little bit higher than that. So maybe like 12, 13, something like that. Now we need to just go down here to shape and this pin group. This is important. We want to make sure to enable this spine 007 pin group. That way it'll pin these top vertices here, so that way they don't fall down through the floor. Now we also need to enable collision on May's head because this mesh here, we don't want it to intersect through May's head, of course. So if we select her head here, we need to do the same thing in order to enable collision. So I'm going to go up to this object tab, create an override on her head, go back to physics, and then just enable collision. Now here I'll just set the thickness outer to 0 because we don't really need any thickness there. These settings here, the damping and the friction, you may need to experiment with for your scene. So we're just going to do a test first, see how it looks. And then if we need to, we can come back and make adjustments. So I'm going to select the cloth object here, and I'm just going to go down to cache, and let's simulate the first 100 frames to see how it looks. So I'm going to zoom out here, save the scene, and now just hit bake. Once it's finished baking, it should look something like this. So if I select it here, you can see. Now it looks like one of the strands here is glitching a little bit. It might be the ear that's intersecting. So we might need to adjust some of the collision settings here. But if I just go here, it looks like it made it to frame 100 pretty well. I'm going to go ahead and just delete this bake here. And I want to adjust the collisions right here. Distance, it might be because the scale of my scene is a little bit different. So I'm going to lower this all the way down to 0001 like that. And now I'll just bump this up to 12 for the quality steps. And the end of this scene, so because we offset it by 150 frames, we need to then adjust the start and end. So I'm going to start it on frame 151, and then here for end, I'll do 293, and I'll just do plus 150, and that will add 150 frames onto the end there. So that's frame 443, so I'm going to do end 443 for the cache simulation right here, and then I'm going to hit bake and be back in a sec. Okay, so we finished up baking it here. and it's looking pretty good. I did have to go back a couple times and adjust some of the settings, so I increased the quality steps a little bit more. I'm still getting some glitching and some wobbling around that I didn't like. And then also here, the vertex mass, I lowered it a little bit, which can help with dialing down the movement a little bit. And increase the speed multiplier, and also down here under the collisions, there's also a quality setting for the collision, so just upping that a little bit as well. Now, if we have a look through the camera, you can see it's a bit hard to see it because it's blocked off by the hair, but it looks like it's working pretty nicely. So the last step is simply going to be to constrain our hair controls to these empties right here, which are following along with the simulation. So that's pretty simple to do. We just have a script right here. In the text editor, I imported the constrain bones to empties script. It's a short one here. All we're going to do is go into pose mode here, and I want to select all of the hair controls. So if we just click on one, then do Shift G, and then we can select a similar type. So we can select all of the other bones in this bones collection. So if I click that, it'll select all of the hair controls. And now I'm simply going to just hit run script. And all it did was it added a constraint onto each of these controls, and it set the target as the empty, which the empty shares the same name as the control. So it just literally just took this name and just put it in right here. And so as you can see now, the hair controls are following along with the empties and with the simulation. Now they are locked to it, so you can't really adjust them. It is of course possible with a bit of extra work, potentially to create an extra offset chain so that you can constrain these to the empties, but then also have control over the hair at the same time. But that's a bit beyond the scope of this video. So in this case, what I would probably do is I would just bake all of this animation here by going to pose, animation, bake action. And then here just doing overwrite current action and visual keying and clear constraints. So it'll take all of the movement that the controls are inheriting from the constraints and actually put them down as keyframes. And from there, you can take that animation and then adjust it as you need. So if we just have a look here, I don't quite have real-time playback, but you can see some of the animation. Now, if it's too much, the nice thing with this is that because we have a constraint, it has an influence slider. So if I just hold down Alt to propagate these changes to all of the current selection, and then just move the slider down, you can see, maybe better see it here on this frame. You can see the influence of that constraint turning on and off for the controls. So if we wanted maybe like a 50% effect, so we want 50% of the movement to be transferred onto the hair just to give it a little bit of movement, but not quite as much as the simulation, we can do something like this. All right, and then you go back here, we can just turn off the simulation collection here. And I forgot to do this, but also in the original rig, we need to turn off the render, disable and render button right here to make sure that the cloth simulation object doesn't actually render once we do a final render. All right, so if we have a look now, you can see how the hair has a little bit of subtle animation and it follows the gravity of the scene by pointing down, and it saves us a lot of time doing that manually. Now, one last note is if you did want to implement this into the actual rig so that you don't have to run that script in the scene every time, you can potentially have these constraints in the rig file and then have either a driver or another Python script like turn into a button or something that can toggle these constraints on and off. That would completely depend on your workflow and how you want to approach things. But for these kind of one-off scenes, I like to set it up sort of semi-locally. All right, that's it for this video. Hope you learned a few things, and thanks for watching.